1.
In section 2.1, we are going to be working with frequency distributions and their graphs. So what we want to start out with is quite a bit of vocabulary. To start with, we'll talk about raw data. Raw data is data that is in its original form. So this may be in tallies if you were counting objects, or it could be the survey responses, but nothing has been done to it. It's just the original data. Then what we often do with that data is create a frequency distribution. A frequency distribution is when you take data and you organize it into a table. Using something that we call classes or intervals. More on those later. And frequencies, which we also call counts. So we take that raw data and we start to put it together in a way that an outside observer could look at it and start to make some conclusions. Now, when we work with these classes, there are some requirements when we set them up. So the classes must be mutually exclusive. In order for classes to be considered mutually exclusive, well, the reason for that is so that one piece of data has a definite class that it belongs to. It couldn't fit into two different categories. So each data value only fits into one class. So there can't be any overlap between your classes. Classes must be continuous, which means that there are no gaps. So, for example, even if I don't have any data in between the numbers, like say I only have numbers that go between 0 and 4, and then I don't have any 5s or 6s, I can't just skip and go 7 to 10. That's not okay. I have to cover all of the possibilities. So I'd have to go like 0 to 4, and then 5 to 9, and then 10 to whatever, 14. They have to be exhaustive, meaning that you have to list them all to cover all of the raw data. So let's say like most of my numbers are between 0 and 10, but I have one random number that's like 40. I would have to list all the classes to get all the way up to 40. They must be equal in width. So I can't go like 0 to 4 and then 5 to 20. They have to be the same size. So if I go 0 to 4, that covers 5 numbers. Then I'd have to go 5 to 5, 6, 7, 8, 9, 5 to 9 to make them all the same width. Now there is an exception, and that's when you have what we call an open-ended distribution. So let's say an example of an open-ended distribution is like when I'm talking about ages. So if I went from 0 to 9, and then 10 to 19, 20 to 29, 30 to 39, and then I just went 40 and up, That's what we call an open-ended distribution. So we're allowed to kind of violate that equal in width when we have that situation. Okay, let's talk about class limits. There is something we call a lower class limit. And then we have an upper class limit. And it does not have to do with like SES. It has to do with these two numbers. So like in this example, 20 would be a lower class limit and 29 would be an upper class limit. So a lower class limit is the smallest data value that is included in a class. So in the example that I put up here would be 0, 10, 20, 30, and 40. Then the upper class limit is the largest data value included in a class. So in my example up above, those would be 9, 19, 29, 39. And then that open-ended class doesn't have an upper class limit. Now we use those upper class and lower class limits to determine something called class width. And we're going to need to know how to find class width to make some of our distributions. Some of our different graphs and charts that we're going to make later. So class width is the difference between the upper class limits or the lower class limits. And it should be the same for an entire distribution. So the way that you calculate class width is you're either going to take an upper limit minus an upper, or a lower limit minus a lower. So for example, if I take an upper limit of 29 and I subtract another upper limit of 19, then my class width would be 10. And if I do a lower limit, say 30, minus the next lower limit, which would be 20, that gives me a class width of 10. So when you're calculating class width, it's never going to be an upper minus a lower. It's always upper minus upper or lower minus lower. So make sure that you keep that straight. Then we have something called class boundaries. Now, class boundaries are kind of bizarre. What they do is they're going to go one decimal place further than the class limits, and they always end in a 5. So I'll tell you their purpose, and then I'll go back over that information. So the purpose of class boundaries is to separate the classes so there are no gaps or overlaps in the distribution. So what they do is they go one decimal further than the data, and they always end in a 5. So for example, for the class 20 to 29, the boundaries are going to be for 20, we're going to go one decimal further. So instead of 20, it'll be 20.0. And I'm going to go down by a half. So that would be 19.5. And then my next one would be, my upper boundary would be 29.5. So that in my next class, which is 30 to 39, my boundary starts at 29.5 and goes to 39.5. Now you'll notice that the class boundaries, if I subtract the upper class boundary minus the lower class boundary, that does give me my class width. So we'll talk about how to use that to construct a frequency distribution from a data set here in a little bit. Actually, right now. So what I'm going to do is give you the instructions, like the step-by-step instructions on how to construct a frequency distribution, and then we'll put that into practice using an example. So here's the instructions to construct a frequency distribution. The first thing you're going to need to do is determine the number of classes. Now, sometimes that will already be done for you, like the problem will tell you how many classes to use, and sometimes you will have to make that decision yourself. So a good guideline is to use between 5 and 20 classes so that patterns are easier to detect. Any more than 20 and there's just too much information going on, any fewer than 5 and there's not enough to pick out patterns. So that's going to be our rule of thumb. The next thing you're going to do is figure out the class width. The class width is going to be found by taking the range of the data and dividing it by the number of classes. Now, range is not something that we have talked about so far, but you probably remember that the range is the highest data value minus the lowest data value. So we'll use the range divided by the number of classes that we've decided. Now, when you divide that, most likely it's not going to be a whole number. Even if it is a whole number, we're always going to do some rounding. So we are always going to round up to the next convenient number even if the quotient was a whole number. So, for example, if my range was 65 and I wanted 13 classes, I would do 65 divided by 13, which gives me 5. But then I'm going to round that up and use 6 for the class width. We always round it up to the next whole number or the next convenient number. And the reason for that is if we don't round it up, then when we get to the end, we will not cover our last piece of data. Our last class would not quite reach all the way to our highest data value. So keep that rule in mind. The next thing we're going to do is determine the class limits. So when we determine the class limits, we're going to start out by selecting the lowest class limit. Now, when we do that, that can be the lowest data value, but it also could be a convenient number that is lower than that. So what that means is, let's say my lowest piece of data was 51. Well, maybe instead of starting at 51, I would want to start at 50 because that's a more convenient number to work with. So you have a little bit of flexibility there. Then what we will do is take your lower class limit and we are going to add the class width that we just got in the other step. And that is going to give us our next lower limit. Then we will figure out the upper class limits. Once you know all your lower class limits, you can find your upper class limits because they are one off from the lower limits. So if one of my lower limits was 18, then my upper limit would have been 17. So those are pretty easy to come up with. Next thing we'll do is tally the data. Now this is absolutely the most tedious part of this process. When you tally that data, you want to make sure that you are very accurate because the entire rest of what we're going to do is going to depend on our tallies being accurate. If you get one tally in the wrong section, in the wrong class, then many of your other computations will be wrong and your graphs will be wrong. So make sure that you're careful when you tally, even though it's kind of boring. Next, you will find the frequencies. Now, for the frequencies, we use this often enough that we are going to represent the word frequencies using the letter F. So anytime we use the letter F, that means the frequencies. So other words for the frequencies are the counts. So in other words, you're going to count up how many tallies or the number of data values in each class. So if your tallies are accurate, all you got to do is count them up, and that's going to give you your frequencies. Now, some other symbols that you might want to be familiar with as we go through, because we'll use them consistently all semester, is this little symbol here. That symbol is called sigma. It's the capital sigma. We'll also have lowercase sigma later on. And what it means is the summation of values. So if I said like sigma x, that means add up all the x's. If I said sigma p, that means add up all the p's. And then the letter n, and we'll consistently use the letter n to represent sample size. And that is the number of data values that you'll be working with. Okay, next up, we are going to do an example. So you should have a handout with all of the examples written on it. This is the one we're going to be doing. So if you want to cut that out and tape it into your notes, that's what I will do with it so that I have it handy to refer to. So, oops, this is page 3. So if you're not quite ready, just pause the video and then come back when you are ready. And I'm going to go ahead and get started. So we are supposed to construct a frequency distribution, and we just got the instructions for that a second ago. So keep those handy to refer to. It tells us that this data is the prices in dollars for 30 portable GPS navigators. We are supposed to construct a frequency distribution that has 7 classes. So they've told us how many classes we're going to use. So remember, that was like number one on our list of things to do, was determine how many classes. So for step 1, we are going to use 7 classes. And then step 2 was to figure out the class width. And the class width, remember, we take the range divided by the number of classes, which I know is 7 classes. For the range, I need to take the highest data value minus the lowest data value. So you just want to scan through all of the data on there. And it looks like 340 is the highest. So I'll take 340 and subtract the lowest, which looks like that is 65. So 340 minus 65, divide by 7. Oops, you cannot see that. There we go. So that's 39.2857, and that keeps going on. But remember, on class width, we always round that up. So what we're going to use for our class width is going to be 40, because we always round that up to the nearest, the next whole number. Next, step 3, first lower limit. And then we're going to go from there to figure out our next lower limit, and we'll actually start going ahead and making our chart here in a moment. So our first lower limit, our lowest data value is 65, which seems like a pretty convenient number. So we will use 65. And then remember, to get the next one, what we're going to do is take our first lower limit, 65, and add our class width of 40. So our next lower limit will be 105. And then we're going to continue doing that over and over and over until we have our 7 classes. So our first one starts at 65. Our next one will start at 105. So I'll go ahead and start a table here with my classes over here. And they are going to go 65. The next one was 105. The next one would be plus 40, so 145. Add 40 again, 185. Add 40 again, 225. Add 40 again, 265. And add 40 again, 305. Now to get my upper class limits are 1 off from my lower class limits. So my first class here is going to go from 65, and it doesn't go up to 105. It goes 1 fewer than that, so it's going to go up to 104. And then from 105 to 144. So what you'll notice here is that I can just keep adding the class width onto my upper limits, or I can keep subtracting 1 from my next lower limit. So I could either do 144 plus 40 to get 184, or I could take 1 off of 185 to get 184. Whichever way you do that, you should get the same numbers. Till I get to here, and then I have to add 40 onto the 304 to get to the 344. Okay, next thing is to tally the data. So I'm going to make a column for tally. Okay. And literally what you've got to do is just go through the data one at a time and put tallies. So if I look at my data here, let's see if I can get it all in one shot. There we go. So I go 128 would go in this section, and then 200 would go here, 110 would go here, 100, 65, 126, 180, 230, and then 170. So 230, 170, 150, 150, 132, 150, 150, 132, 200, 150, 140. 200, 150, 140. So remember, after you get the 4 tallies, then the 5th one will go diagonal, so that makes it faster to count later. 90, 120, 112. So 90, 120, 112. 340, 130, 90. 40, 30, 90. I'm just going to finish this up without talking so that you can also finish it. Okay. After we've got the tally, the next thing was the frequencies. So I will just label that column as F. And then we just look here. I've got 6 tallies here, 9 tallies there, 6 tallies here, 4, 2, 1, and 2. Now, there are going to be some other things that we're going to do with this chart, which is why I've left this space here in a second. But one of the things that we will often do is count up the frequencies. So remember, the symbol for count up or add up all of the was that summation symbol, which was the capital sigma. So if I write this, that means I'm going to add up all of the numbers in the F column there. So if I add up all the numbers in the F column, 6 plus 9 is 15, plus 6 is 21, 25, 26, 27, 28, 29, 30. So the sum of the frequencies is 30. Now we should already kind of have known that because it tells us the price of 30 GPS systems, but that's always a good check to make sure that you have everything tallied appropriately. Alrighty. Also, by the way, this is our sample size, which we use the letter N for. Okay, some more things that we want to do with this. One thing is that we will want to be able to find midpoints. So let's see, I'll use my black marker for that. So let's talk about class midpoint. A class midpoint is also called a class mark. But mostly I will be using class midpoint. So to find the class midpoint, what we're going to do is you're going to take the lower limit for the class plus the upper limit for the class, and you're going to divide that by 2. So we'll make a column for that, and I'll show you what's going to happen. So we'll have a class midpoint. And what we're going to do is you take the lower limit, 65, plus the upper limit, 104, and divide it by 2. So 65 plus 104 is 169. Divide by 2 is 84.5. So my class midpoint is 84.5. And then I'll do that for the next one. 105 plus 144 divided by 2. 105 plus 144 divided by 2 is 124.5. Now, hopefully you notice that my class midpoints are also 40 away from each other. So I can just take that class width. Once I've got my first class midpoint, I can add the class width on and generate the rest of my class midpoints. That's a 5. And 324.5. All right, moving on. The next thing that we're going to talk about is relative frequency, and then we'll talk about cumulative frequency. So, relative frequency. Relative frequency can be given as a fraction or a decimal or a percent. Those will all be equivalent to one another. What we're going to use in our table is going to be a decimal. And what it tells you is the portion of the data that fall in each class. So like 10% of our numbers are between 225 and 264, for example. That's not really the right number, but we'll see how those work. And then to calculate relative frequency, what we're going to do is we're going to take the frequency, the total frequency, divided, or excuse me, the not total frequency, the class frequency divided by the sample size. So this is class frequency, which will be found in the F column that we created, divided by sample size, which was the total number of data values. So we'll do that here. We will make a column for relative frequency. So we're going to take the number in the class, so 6 divided by the sample size of 30. And so we'll do 6 divided by 30. And we'll just use a decimal, so that is 0.2. And then we just continue doing that for each of our classes. So relative frequency here will be 9 divided by 30. 9 divided by 30 is 0.3. And we just keep going like that. So 6 divided by 30 again is 0.2. We've already had that one. 4 divided by 30 is 0.13. We'll just go to 0.13. 2 divided by 30, we'll call that 0.07. 1 divided by 30, 0.03. And then 2 again would be 0.07. Now, if we add this up, the sum of F divided by N, the relative frequency when we add it all up together should equal 1. Now, based on rounding, that may or may not happen, but the sum of the relative frequencies should equal 1 when you add them all up. 0.2, 0.3, 0.2, 0.13, 0.07, 0.03. Ooh, yes, it does equal 1. Then we have something that's called cumulative frequency. Like cumulative means kind of you keep track of it all along the way, I guess. It's kind of similar to your cumulative GPA. It's everything from this year and down below it. So cumulative frequency is the sum of the frequencies for the current class and all previous classes. When you get to the end, the last class, cumulative frequency should be equal to the sample size, which, remember, the letter we used for sample size was N, which we also found was the sum of the frequency column. So For cumulative frequency, in that first class, we've only had 6 so far, so cumulative frequency is 6. In our next class, now we've already had 6 before, plus we add 9 more, so that is 15. Then in our next one, we add 6 more into the mix, so that's 21. Then we add 4 more, 25. Then we add 2 more, 27. Add 1 more, 28. Add 2 more, 30. So that is cumulative frequency. And we're going to use all of the different ideas here for different charts and graphs and diagrams that we're going to make as we go through. So we'll talk about each one of those individually, starting with a frequency histogram. So first I'll kind of give you some features of a frequency histogram, and then we'll create one. In a frequency histogram, the bars are going to be touching each other. So there will not be a space. There should not be a space between them. The y-axis will be the frequency, and the x-axis will be one of two things. You will either use class midpoints or class boundaries. So we're going to make 2 frequency histograms for our data that we just worked with on the other page. One is going to be using midpoints, and one will be using class boundaries. Remember that class boundaries are 1 decimal point past the class limits, and they end in a 5. Okay. So we'll put those together when we get to that. So let's do our first one using midpoints. So I'm going to start with an axis here. Let's see. I want a straight edge. Remember that my y-axis is going to be frequency. And my frequency, the highest one I had was 9. So I'm going to go ahead and make my top frequency 10. And I think I'll just go by 2s. So that will be 8, 6, 4, 2, and I have given myself too much space. But to rather have too much space than not enough. And then my horizontal axis, my x-axis, is going to either be class midpoints or class boundaries. I'm using midpoints this time. My first midpoint was 84.5. So I need to show that there's a break in my axis. So I use that broken axis symbol there. Otherwise, it looks like my data would start at 0. So I'm going to start. I have 7 classes, so I want to kind of evenly space them. So I'll go here. This will be 84.5. So 1, 2, 3, 4, 5, 6, 7. And I'm going to label those with my midpoints. So those were 84.5, and then 124.5, 164.5, 204.5, 244.5, 284.5, 324.5. And I'm going to label this axis here with frequency, but more specifically, it is the number of GPS units. And then over here, I'm going to label this price in dollars. And I might label it midpoint of classes, just for jollies. And then I'm going to use the frequencies to create vertical bars that are going to be touching. And since these are my midpoints of the classes, it's also going to be the midpoint of my bars. So my very first class had a frequency of 6. So I need to make a bar that is 6 tall, and it's going to like straddle that 84.5, if that makes any sense. So I might kind of make halfway marks. So for my 84.5, that needs to go up to a height of 6, and then over. And you can label those with numbers if you'd like. And then my next class had a frequency of 9. So that's just going to be touching this one. So I'm just going to extend that up to 9, and then over and down over here. And then my next class had a frequency of 6 again. And then the next class was 4. Oops, I got a little off track there. And then 2. And then 1. And then 2 again. So that is what a frequency histogram looks like using class midpoints. And then we're going to make one that uses class boundaries. So let's figure out what our class boundaries are based on our class limits. So remember that our limits were 65 to 104, and then 105 to 144, 145 to 184, etc. I'm not going to write them all down. Then let's figure out what our boundaries are. So our boundaries are going to go 1 decimal point further than our data. So instead of going to the nearest whole, they're going to go to the nearest tenth, and they always end in a 5. So instead of going 65 to 104, I'm going to go in between 104 and 105 to 104.5. And that means I need to go back by a half. So instead of starting at 65, my boundary will be 64.5. And then my next class will start at 104.5. And then my next one will start at 144.5. So then from here, I can just add my class width on. So from 104.5, add 40 to 144.5, add 40 again, 184.5, etc. So however is the easiest for you to construct your boundaries. They're not going to be fun to write on our scale because there's lots more decimals and whatnot, but it's not like it's difficult, just kind of pain in the patootie. So we're going to start it again like we had the last one, with frequency on the vertical axis or the y-axis. So that'll actually be labeled the same way. Frequency, number of GPS units, and then the horizontal axis will again be price in dollars. And if you want to label it that you're using class boundaries, you can do that so people know. And again, we need that broken axis to show that we didn't start at 0. And we'll evenly distribute our boundaries. And then we're going to label those class boundaries. So my lowest boundary was 64.5. So I'll need to label this 64.5. And then I'll label this one 104.5. And then 144.5. And then 184.5. 224.5. 264.5. 304.5. And then our last one, 344.5. And then we're going to do the same thing with our bar heights, except for this time, since we're using class boundaries, it's not going to straddle the tick marks. It's going to go from edge to edge on the tick marks. So I'm going to go from 64.5 to 104.5, had 6 in that class. So that bar is going to be touching the two boundaries. And I can label that with a 6 again. And then I start from this edge again and go up to 9 on my next one. And then my next one was 6 again. And then 4. Oh no, I've messed this up. Can we pretend that didn't happen? So just pretend that these numbers are labeled up here. And try not to mess yours up. Darn it. I hate when I mess stuff up. Oh well. So 4. And then 2. And then 1. And then 2 again. So if I hadn't messed up my graph, what you should see is that the shape of these two distributions is exactly the same. The differences are that when you use midpoints, your bars go across, like the midpoint is in the middle of the bar. And when you use boundaries, the boundaries are on the edges of the bars. So you'll need to pay attention to those details, because although when you are doing your assignment in my math lab, you'll mostly be choosing from provided graphs, you need to be doing these graphs by hand before you make your choice, because otherwise, when you go to take your test, you will not be paying attention to those sorts of details, and then you'll lose points because you're not doing your graphs correctly. So please make sure that you practice doing these graphs by hand and paying attention to those details along the way. So let's look at our next type of display, which is going to be a frequency polygon. Now, frequency polygons, kind of what they do is they use line segments to connect the frequencies of midpoints of each class. Now, you'll be able to tell a frequency polygon, like they have a specific look to them. What's going to happen with a frequency polygon is that you will have the frequency along, okay, I didn't spell that right, but that's okay. You'll have the frequency along the vertical axis just like before, and then you're going to have the midpoints along the horizontal axis. And what you're going to need to do is you're going to need to create 2 additional midpoints, because a frequency polygon is going to begin and end on the 0 mark. So we'll have frequencies different places, and then you connect the dots using straight line segments. But you begin and end along the on the horizontal axis, on the x-axis. Okay. So with our example that we've been working with, we'll do the same problem that we've had all along. Remember, our highest frequency was 9, so we'll go 10, 8, 6, 4, 2, and I'm not going to mess this one up. Now, since we had 7 classes, we had 7 class midpoints. But remember, we have an extra at the beginning and an extra at the end. So we are going to need 9 little ticky tick marks. So I'm going to make 9 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not going to label the first one. I'm just going to go through and label the ones that we had for our midpoints of our data. The first midpoint we had was 84.5. And our next midpoint was 124.5. And then 164.5 to 04.5 to 44.5 to 84.5, and our last midpoint was 324.5. But we have to have an extra at the beginning and an extra at the end. So to get the extra at the end, we just add the class width again, which was 40. So this one will be 364.5. And then to get the extra one at the beginning, we subtract the class width. So 84.5 minus 40, so 44.5. Now, since there was no data in this class, we put the frequency at 0. And since there was no data at this class, we also put the frequency at 0. And then our other ones will be what they were before. So at 84.5, the frequency was 6. At 124.5, it was 9. And then 6 again. And then 4, I think, 4. Yeah, so ignore that. And then 2, and then 1, and then 2. So then we're going to connect those dots with a straight edge. Too many things. And you can tell it's called a frequency polygon because a polygon is a closed figure. So you can see that if you don't do the one at the beginning and the one at the end, it won't be a closed figure. So it won't be a polygon. So you might want to add that onto your cheat sheet, some of those really important details. And I did forget to label my axes. So frequency and price in dollars. So that is a frequency polygon. Then we are going to next make a relative frequency histogram. So instead of having our frequency on our vertical column, we are now going to have relative frequency on the vertical axis. And remember that relative frequency was the frequency for the class divided by the sample size. Then for the horizontal scale, just like we did with our frequency distribution, our frequency histogram, you can use midpoints or class boundaries. I think let's only do one of them, just in the interest of saving time. So for a relative frequency histogram, the general shape of that is that we will have either midpoints or boundaries along the horizontal axis and relative frequency on the vertical axis, which means the highest it could possibly go is up to 1. It can't go any higher than 1 because that's 100% of the data. So you'll be able to tell a relative frequency if the scale over here is like 0.1, 0.2, 0.3 and doesn't go any higher than 1. So we had a column in our frequency distribution that was for relative frequency. It was this column here. So we're going to be using that to create our frequency distribution. And I'm going to choose to use class boundaries, because we just did one that had midpoints. So using class boundaries, our relative frequency let's just go 0.2, 0.4, 0.6, 0.8, and 1. And since we're using class boundaries, we need 1, 2, 3, 4, 5, 6, 7, 8 of the little tick marks and the little separation guy there. And we'll label this price in dollars. And relative frequency, another way of thinking about relative frequency is it's going to be the portion of GPS units rather than the number of GPS units in each of those price zones. So we had gone 64.5, 4.5. Since I'm using boundaries, and then we will use relative frequency of 0.2, and then the next one was 0.3, and the next one was 0.2 again, and then 0.13, 0.07, 0.03, 0.07. I think I've messed up somewhere. Oh, because I'm not supposed to make them look like that. These are going to be a histogram, so they're going to be bars that are touching. Sorry, I'm trying to rush because my computer is giving me warning signals. So